Perfect. With that, let's get started. Welcome to our today's webinar about the thickener application of BASF Intelligent Mine powered by IntelliSense.io. Thank you to everyone who has joined today's session. In today's webinar, we will be discussing how the newly launched BASF Intelligent Mine, and in particular the thickener circuit. Before I introduce you today's webinar's hosts, Ken and Neil, I'll kick off the meeting today with some housekeeping. Today's webinar will run for 1 hour. We'll first hear some background information about BASF Intelligent Mine and the partnership between BASF and IntelliSense from Ken. And then we will throw to Neil, who will take us through a demonstration of the tool. If you have any questions, please type them into the chat box to myself. And at the end of the session, I'll lead a Q&A with Ken and Neil, and we will read out any questions I received in the chat box. If you are experiencing any technical issues, please send me a chat message too, and I'll do my best to help you out. At the end of the webinar today, we will send out a recording of the webinar, so if you do have any tech issues or miss anything, rest assured you will receive a recording of the session. Now, to introduce the host of today's session, first we'll hear from Ken Plosser, Head of Global Digitalization, BASF Mining Solutions. With a first-class honors in applied chemistry from Curtin University, Ken has over 25 years experience in the chemical industry, with careers in R&D, quality control, procurement, production, site management, sales, and marketing. He is currently responsible for the global digitalization activities across BASF Mining Group, including MPS, CRM, and the BASF Intelligent Mine partnership with IntelliSense.io. Ken is based in Melbourne. Neil Knoblauch is a product lead at IntelliSense.io, where he manages IntelliSense.io's digital plant suite of optimization applications. He works with IntelliSense.io's field operations and product development teams to ensure that they develop best-in-class products that deliver measurable value to the mining operations. He has a master's degree in process engineering, extractive metallurgy, from Stellenbosch University, and prior to joining IntelliSense.io, Neil worked for Minetech as an advanced process control engineer, designing and implementing solutions for minerals processing operations throughout Africa. Neil is based in the UK. And with that, enjoy our today's session, ask questions if you want, and I'll hand over to Ken.
Thank you, Natalie. Just a quick recap. So I'll take you through the slides, and then we're going to present a video that Neil has created that'll take you through the product, and then both Neil and I will be available for Q&A. So with little to do, let's get started. So the relationship between BASF and IntelliSense. We began our partnership back in late 2018, and together we've now been developing and trialing digital products on trusted client sites, seeking to extract the most out of our individual skill sets. Now, BASF, big chemical company, now we've always recognized that chemistry needs the best control to allow all of its value to be extracted. So we wanted to partner with somebody that would allow us to digitalize our knowledge, but also to create tools to extract as much value from chemistry and process as possible. IntelliSense, now they recognized that the data collected by the mining operations held significant untapped potential, and it would offer insights into optimizing performance. So we joined together and integrated into all of our digital products are now BASF's extensive mining knowledge and chemical interactive expertise, plus IntelliSense's industry-leading advanced data analytics, their software engineering, and their vast mining industry experience. The BASF Intelligent Mine, powered by IntelliSense, is the result, and it combines the very best from both BASF and IntelliSense. The result is a synergy between chemistry and advanced data analytics, unlike anything else in the market today. It's like having your best operator in the control room 24/7. So what is the Intelligent Mine? So what we offer is optimization as a service-based solutions that require no capital investment and have an implementation of between 3 and 6 months with immediate results. Our technology sits on top of your existing infrastructure and makes use of your current instrumentation and process control systems. This super low risk approach allows you to then implement our technology with little or no interruptions to your current systems and provide you with instant value. The initial implementation and ongoing subscriptions have a target return on investment of between 5 and 6 months from implementation. The applications themselves, they're all out-of-the-box solutions. They're ready now. They're ready for each process from the mine to market value chain. And what we do is we'll initially deploy and configure and calibrate the applications in the area of most need for you. Then additional applications can be added to your system. Once fully connected, each of these applications optimizes its own behavior, but it also works with the other applications to produce an overall product efficiency. They all have a decision optimizer incorporated into each of them, and this is there to help provide real-time set point recommendations based on process improvement targets, which are typically set by you, the user. The system then provides recommendations to control room operators for optimized control. The solutions based around AI, they combine physics-first principles with machine learning and AI models to draw patterns from the data using neural networks. Our models also learn and adapt in real time to evolving situations, which is pretty normal on a mine site. We've currently developed applications covering the areas listed there to the right of your screen. So let's have a bit of a look at each of the applications before we dive into the thickener one. Clicking always helps. So digital stockpile. So in the digital stockpile management application, we take material data like 3D block models and material handling data like GPS information from your truck and dozer movements, and then we create real-time 3D models of your stockpile. From this model, we can deliver insights into the composition of the stockpile at a granular spatial and time level far exceeding your current levels. These insights can then be used to plan the creation of future stockpiles, plus deliver predictions of the material characteristics as it's reclaimed and fed to your processing plant. Our heap bleaching application uses the same models as our stockpile, and it tracks spatial deposition and reclaiming from heaps. This improves the visibility of the material, the contents of the heap at a granular and spatial level, and allows increased metal recovery by adjusting liquor volumes and residence times in response to knowledge of what is and where is things in the stockpile. The application also predicts the difficulty of reclaiming a specific heap and recommends maximum reclaiming rate targets to avoid rotary bucket evacuators getting stuck, causing downtime and lower than normal yields. The grinding application. Now, what we do here is we focus on providing information about the current state of your mill. So we look at things like ball charge, your liner state, and the actual contents of the mill. From this, we can start to predict things like your mill bearing pressure, your mill overload probabilities, and this allows your operators to make proactive decisions to avoid overloads and associated throughput issues. Now, here we provide a lot of virtual sensors. So these are things like gas holdup values in real time. And we integrate with the IntelliSense material model to give insights and predictions into the effects of your feed conditions on a circuit. And this allows your operators to optimize the performance of the actual flotation circuit in real time. Pipeline pumping. Now, this application simulates pumping schedules in pipeline systems hours into the future, and it optimizes pumping to balance the specific energy consumption with pumping switches according to operator preferences. It automates your pipeline operations to meet variable demand while maintaining the optimal balance between energy consumptions and pump wear, freeing up operators to focus on other tasks. The purpose of this application is there to eliminate the CapEx that would be normally needed to install VSD drives, as you can run this off normal switching paths. And of course, the thickener circuit. Now, before we talk about that, let's have a little talk about the architecture of the intelligent mine, and just to reiterate what we have. What we need to remember is that the intelligent mine sits on top of all of your existing processes. So the instrumentation that you currently have on site, the sensors that you have on site, the data that you collect, both historical and live, plus your existing control systems, are all used as inputs and outputs for our system. BrainZap then provides an integrated platform on top of it to analyze that data lake, create models from that source. It hosts our applications, of course, and it supports the prediction, optimization, and simulation energies for each of our applications. Specifically the thickener. Now, many operations experience the same thickener problems all over the world, and those challenges, our application tries to actually address them. So most thickener circuits are generally characterized as unstable, if you're lucky, with dynamic feed characteristics associated with ore body changes, variable feed rates to the thickener, maybe changes in your feed density, changes in pH. These are all compounded by poor flocculation addition, maybe floccular dilution, and even the mixing conditions. Thickeners are often then controlled very reactively by your SUF, with large changes being made to control set points as your operators near torque or bread pressure or underflow density limits. Additionally, differences in control philosophy across shifts or even across individuals, added to staff turnover and loss of process knowledge, also impacts overall operational reproducibility. The result is further instability, and sometimes thickeners are then run from one extreme to another. As a result of these challenges, balancing thickener operations to obtain consistent, stable results is difficult and results in the density of tails or concentrate not being optimized, maybe water recovery is not maximized, chemical usage is not balanced to the actual performance outcomes needed, and the thickener can become unstable, resulting in being a potential bottleneck to the rest of the plant. So by applying the BSS Intelligent Mine thickener application, the result is a thickener process that achieves the targeted KPIs set out by the site, giving transparency on cost and performance, plus live simulations and analysis tools to allow your team to understand the process better. So this is an example of the sort of control improvements that can be seen when you run through the actual thickener application. So what we have on the screen here is down the bottom is it's a bed pressure sense. So you've got the before, the during, and after. And what you find is when BrainZap takes control and starts giving the optimized recommendations, our control improves dramatically. So what we've done here is shown you that in a histogram. So the original control is this orange line, and you can see that we regularly pass the limit. But once we get under IntelliSense control, the system pushes hard up against the limit. And these few items here that are just above the limit, that's really the beginning as we've got it back under control. Just quickly looking at it, 31% of the time you're breaching limit under standard operation, but under the IntelliSense model, we're at 5. This resulted in changes to your underflow density. So when you now look at underflow density, the entire curve is now moved to the right, and the overall average underflow density has improved. So this is the results of actually implementing the actual thickener control software. So what we're going to do now is get Neil to run through a video which will actually take you through the actual product.
Thanks, Ken. My name is Neil Knoblauch, Product Lead at IntelliSense.io. I'm really excited to give you a demonstration of our thickener application today. Mining companies lose out on significant revenue due to inefficiencies and instability in subsequent processes. Nowhere is this more true than with thickeners. Whether concentrate or tailings thickeners, these are generally processes with large residence times, and there's often a lack of clarity, excuse the pun, of what's actually going on inside them. So by the time you realize what's going on, it's often too late. You might need to stop to hose out the thickener because the solids have built up beyond repair, or the thickener might have started sliming, contaminating process water. Control systems out there are battling to stabilize, not to mention optimize these circuits, as they fundamentally cannot cope with these challenges. At IntelliSense.io, we developed an optimization system to specifically address the challenges that we've seen in industry. We equip and empower metallurgists, operators, and plant managers by providing a degree of transparency not available with other systems. I will now show you the thickener circuit optimization application in action, or as we call it, the thickener application. What I'm currently showing you is an example of a performance dashboard. Data from different sources, plant sensors, logs, lab analyses, all of these are in one place, coming into BrainZap. And we use this to create a digital twin, or what we call a digital process model of your thickener circuit. Using our in-house machine learning technology, we use your historical data to create a digital copy of your thickener circuit. This digital process model allows you to have an at-a-glance view of how the thickener is performing. With this performance screen, you can not only see historical data and live data, but predictions of the performance of your thickener into the future, an hour into the future as well. Here you can see feed variables, your feed density and your feed flow rate. You can see monitoring variables, your underflow density, and the bed pressure. These are the variables that you want to get right. And also control variables, the variables that you can tweak in order to steer the thickener. In this case, the flocculant feed flow rate and your underflow flow rate of your thickener. The feed going into your actual thickener also goes into this digital copy or this digital process model, and this means that we can predict how it will perform into the future. So as your feed changes, you will now know what will happen downstream, whether a limit will be breached, and you will be able to act before anything goes wrong. Something worth mentioning at this point is that connecting the thickener app to our material model will mean that you can also predict the feed coming into the thickener, its quantity, and also the material properties, which can be further used to enhance the predictive performance of the thickener application. Now that we have a digital version of your thickener circuit, we can set up its value driver. The value driver is what we put into the hands of your metallurgist or operations to define the thickener objectives and limits, to tweak the relative importance of different objectives as well, like maximizing your underflow density versus minimizing flocculant usage. These limits can be easily changed in this value driver. For example, if I want to change the soft limit, upper limit of my bed pressure, I can very easily just enter a new value for it here and submit. These variables set by the metallurgist drive the goals that the thickener circuit will work towards. Now that you have a digital version of the thickener circuit and you've set up the thickener objectives in the value driver, you now have a thickener optimizer. The thickener optimizer is the heart of the thickener application. Now you can not only predict the future behavior of the thickener circuit, but you can actually optimize it as well. So if we, instead of predict, we can click on optimize. Right now you can see that the control variables are constant and that your underflow density will trend downwards. If we click optimize, we'll see what it does. In this case, for this moment, it increases your underflow. It increases the flocculant flow rate and decreases your underflow flow rate to lift that underflow density into the future. Like a car GPS, it always starts where the process is, where you are, and maps out the road to where you want to be as defined by the value driver. And in this way, it ensures that your thickener is consistently pursuing your process KPIs. Now, how are these recommendations implemented? Under the flocculant flow rate and the underflow flow rate, how are they actually pursued by your process? Now, there are two options here. The first one, and the one we normally start off with, is that these recommendations are provided to your operators. This is done via the operator screen. Here, periodically, in this case every 5 minutes, the sound goes off and a new recommendation for the control variables are provided to your operators. For example, if we use underflow flow rate, you can see that the current underflow flow rate is around 880 cubic meters per hour. Within the next hour, we want it to lift to 1,100 cubic meters per hour. But for this next action, it recommends to the operator that they need to change it to 910 cubic meters per hour. The operator will see this when the sound goes off and then enter this value in their SCADA as a set point to a lower level control system, or they might manipulate a corresponding pump or valve directly to achieve this. This means that your operators are engaged and empowered to perform consistently irrespective of shift. And this is why we say that we give you your best operator 24/7. The second option of how these recommendations are provided to your system is to do this automatically, to write these back into your plant, DCS or PLC as set points to a lower level control system. For example, the underflow flow rate of your thickener might be controlled by an underflow pump, and this flow rate set point might be written back to be pursued by this control loop, so it speeds up the pump to get this flow rate to where it should be. This is how your thickener circuit will be optimized in real time. By making the recommended changes, the best performance of the thickener circuit can be achieved as defined by the metallurgist. In addition to optimization, another challenge that we've seen is that once the thickener is lost or something goes wrong, it's hard to figure out why. With a thickener application, we give you that transparency. If I were just to go back to the performance dashboard that I showed in the beginning, if something were to go wrong, you would be able to view your historical data and see, did something go wrong in the feed into my thickener? Did the operators perhaps fail to implement the control variable recommendations? Did my process sensors return any strange data? And even you'll be able to see what's driving the optimizer actions at all times. And this adds transparency to ensure that the thickener app is not a black box, but that the site personnel know what's going on and why at all times. For example, here you are able to see that the optimizer is driven mostly at this point by achieving a desirable flocculant dosage and maximizing underflow solids, percentage solids, and these and the relative importance between these have been set up in the value driver. Additional transparency is added by the predictions having uncertainty bands. Uncertainty bands accompany all our predictions to give operators and metallurgists alike an understanding of how sure the digital process model is of this future, and this depends on things like data quality. You can see the uncertainty bands around the monitor variables. In the unlikely event that the uncertainty goes above a configured threshold, the thickener app will clearly inform the operators on the operator screen and will not provide a recommendation until it's confident again. This transparency ensures that metallurgists and operators can confidently use the thickener optimizer recommendations at all times. Another challenge that we often see is that site personnel often don't know how the thickener circuit is performing compared to its potential. This is especially something that plant managers would be interested in. This can be solved by comparing actual performance with optimized performance. We've created this opportunity dashboard to show that when you trend actual historical data versus optimized historical data, with the actual being in blue and the optimized in red, you can actually put a dollar value on the delta between where you're currently operating and where you can be operating. For example, in this dashboard, the underflow percentage solids is shown, the underflow flow rate. You can see that the underflow flow rate is higher here, and the flocculant flow rate, the optimized case is much lower than the actual case. These are translated into dollar values with our financial model. So you can see how flocculant cost is reduced by the optimizer, how product revenue is increased by increasing the production rate or your throughput of your thickener. And combining these into a single financial model, what we get is what we call an opportunity loss. The potential that can be gained and the potential for continuous improvement. And so in this case, for example, you can see that over roughly a day's period, the opportunity loss accumulates to about $6,880 in metal value over this day. And as the implementation of the optimizer's recommendations are improved, these lines will start sitting on top of each other, and your opportunity loss will move to zero, meaning that you have maximized your value that you gain from your thickener circuit. This gives someone like a manager insight into the financial performance of the thickener circuit, really closing the loop and giving the manager control over his process. The last thing that I want to show you is our simulator. So in addition to being able to predict and optimize performance, there's also the option of being able to simulate behavior. This is something that it's a non-intrusive practice tool. It's risk-free, and so it's a way to coach new employees and operators on how the thickener circuit actually works and what they can expect from its performance. So yeah, under simulate, if I were to enter new control variable values, I can click simulate. The control variables would jump there. This is sent into the digital process model, and changes in the monitor variables will be shown here. This is something that can easily be used in training and coaching. Right, I think that's all that we will have time for in this session, and I'm looking forward to hearing your thoughts and your questions. But let me just quickly recap what we have looked at in this session. We have looked at how the thickener circuit optimization application provides you with predictions of how the thickener will perform as the feed changes. We have seen how the value driver that sets the objectives for the thickener performance are placed in the hands of a metallurgist. So you define what success means for your plant and for your thickener circuit. And we've seen how this then provides you with an optimizer that optimizes the thickener and outputs optimal control variable recommendations that are either shown to your operators, so they implement them, or are written as set points to your lower level control systems. And I've also shown you additional features such as the simulator and our financial model that can show the room for improvement or potential opportunity, and etc. All of this to optimize thickener performance and to consistently hit your KPIs, things like throughput and profitability, but also to create a common in-depth understanding of how the thickener is performing and how to best improve it. We believe that the thickener application is unique in the market today, and that it will also be able to provide you with significant value, so that you always have your best operator 24/7 driving your thickener to optimal performance. Right, I'm looking forward to your questions.
Hopefully that demonstration has given you a nice hands-on feel for what the product looks like and the benefits it can actually deliver for your thickener circuit. We think that combining BASF chemical and process expertise with that advanced data analytics and software engineering of IntelliSense, that we've created a really unique product that's ready for you to use right now. So that's the end of the presentation. What I'll do now is I'll hand back to Natalie and we'll kick off a Q&A.
Perfect. Thank you very much, Ken and Neil, for those interesting information. We already have received some interesting questions. First would be, could you please share where this mining solution has been implemented so far? Are there any references?
So yes, there are. IntelliSense have been implementing these applications globally now for over 4 years. So some of the majors have implemented. Probably our biggest opportunity at the moment is with Anglo America. So we're dealing multiple sites with those guys. But other big majors in South America, also gold mines in Kazakhstan, and we've also had opportunities here in Australia. Some of the names we can't let you know because of confidentiality, but multiple locations around the globe. Perfect.
Thank you very much. Another question would be, how do you protect customer data?
So the number one thing to remember about data is the data is always the customers. The second, what we try to implement here is a hybrid cloud setup so that we use a combination of storing the information directly on your service in your premise, but also in the cloud. We use all the latest cloud technology, all the normal security that you need to keep everything as secure as possible. But the most important thing to remember is that we're extracting the data out and then we're giving you a recommendation back. So at no point are we opening up your system to attack.
Perfect. Thank you very much. Another question we got from our participants is this solution modular?
Modular. So yes, in a way. So what we've done is, if you can remember the technology stack slide that I put up earlier, so the platform itself sits across your technology, and then on top of that platform, we sit the individual applications. So one doesn't happen without the other. So the initial installation is always about getting the material model first, getting your digital twin, the data lake, all those items together so that we have something to work with. From that, we then create our models, and then those models then specifically become the applications. And each one of those applications sits on top of our system. Now, you can implement just one application. So you could start at the front of your process, as an example, and implement a stockpile management system, giving you really good insight into your stockpile. But then you could also implement other things like grinding or flotation or thickening to actually allow these applications then to talk to each other. So the learnings and the understandings a bit too much, the learnings that the actual software gets can be transferred through that material flow into the other applications. In both directions too, by the way. So we can also take that how things react to certain conditions can then be fed back into the previous application to say, hey, learn from that.
Yeah, if I could just add something to that. The word modular is quite an interesting word to use. And so I would say, just as Ken said, one could combine different applications in multiple ways. But I think another way in which this is modular is that during implementation, during the feasibility phase, there will be an identification of which aspects to focus on first to get the most value, but also as implementation goes on, it's modular in the sense that value will be delivered as we go through it. So it's not everything needs to click into place and then you get something. As we work on this, you will get predictions while we configure the optimizer, and when you get the so you'll see your data, you'll see predictions, you'll be able to simulate it and then optimize it, and so in that way, it means that within a month or two, you start seeing value even as the project is still continuing, which is great in that sense. I guess that's a different definition of modular.
Yep, it's good.
Perfect. Thank you very much for this. Hope this answers the question. Another question what was coming in is, how does the intelligent mine work across multiple mines in the same business group over various locations?
Neil, you probably have a better crack at answering that one than I can.
Yeah, so I think there are two parts to that. Across different applications, what we've mentioned was that obviously there's a in the project there's a phase where one will agree which we've got a per site software license as a service, or we also have the enterprise package, and on a company by company basis that will be evaluated, and there's an option of getting an application specifically for a site, application for a company with many sites. But what we normally see is that the enterprise deal normally entails having a number of applications across a number of sites, and that means that yeah, there's a larger project, as I mentioned, of identifying where are those low-hanging fruits, where should we focus across the company. So we tie in with let's say the mining company's change management process, so it's rolled out in a way that fits the culture and procedures of the company. So there are multiple options, and I think that's one of the example of something better to be discussed on a one-to-one basis, so we can better understand what's on the table and what you have in mind.
The other side to that, I think, Neil, is that one advantage of having multiple mines within the same environment itself is that material flow that we sort of touched on at the beginning of the actual presentation can actually extend beyond the mine. So you could have multiple mines in a process that provide, let's say, all of their output then goes to a refinery. So having those multiple mines then feed to a refinery, you might be able to get some insights into the material that's actually coming through from mine to the final end. But there's different ways of looking at that.
Yeah, absolutely. And also, so yeah, in terms of the more you break silos, the more you can really optimize. And so if you can optimize the way a bunch of minerals processing plants feed one single refinery somewhere around the globe, that's something that can be optimized as let's say gold or copper or whatever prices change. How should my operations upstream change? And that's a very nice big optimization issue, optimization problem to solve, which our tools are perfect for. Additionally, there's also the aspect of reporting, the ability to see how all my operations are doing from a high level, from a director management level, seeing everything in one place, a single source of truth. That's also super valuable. It's something that you can trust and doesn't come via Excel spreadsheets that's been filled in by people that are trying to make their sites look good. It's like the actual, single source of truth.
Another side of this is actually making me think here. It's not where the application is now, but our roadmap is that in the future we would like to connect our things together in a really dynamic way. So one of the things that we don't talk about a lot in the presentation thus far is that part of the model of the subscription model is that we have multiple releases. So every 6 months there's an update to the content of the software. In the future, we would really love to see this ability to take not just from sites within the same organization, but this sort of dovetails back into that question about data. But imagine you had 20 thickeners from multiple mines where their data is anonymized but combined together. So now our models have a really large data set to play with to really understand cause and effect. And that's going to be a really interesting future where we start to combine these things together to maybe give the models a bit of a head start in the implementation process, because it comes with a pre-learnt experience that's beyond the current mine. Might not be relevant, but then again, it could be relevant. So it's a really interesting space that we're going to be moving into over the course of the next 12 months to probably 24 months.
Great, thank you very much for this insight. Then our last question, what comes in was, do I, as a customer, buy or lease this app?
So the model is relatively simple. So we're a software for service installation here. So there's two components to the cost. Your initial implementation cost is a sunk cost that's done at the beginning, and that is paid at time and effort. So for a standard implementation, that could be anything from $120,000 to $200,000 US. But once that implementation is done, then what we actually then charge is an ongoing subscription fee. And that subscription fee basically is an annual fee that's paid up front. And that fee then gives you access to the current technology, but more importantly, every 6 months there's new releases. And so we continue to develop the technology, if it's thickener or whatever you've actually purchased, on a 6-monthly basis to ensure that you're getting the benefit of everyone else's learning into your application. So an initial cost up front and then an ongoing subscription fee to take advantage of the advantages that we build into the apps over time.
Perfect. Thank you very much for that. And with that, I want to close today's session. I really would like to say thank you to all of you for participating and joining our today's session. And for more information, or in case if you have any questions, please visit our website or contact us via the shown email addresses here. As promised, we will we will reach out to you via email and share the recording with you afterwards. Maybe you can also use this for some internal discussions with your colleagues. We're looking forward to our upcoming discussions with you, and with that, enjoy the rest of your day, and again, thank you very much.